Oh, hello. Just getting things set up here, getting the link sent out on Twitter. Sorry about the noise. Had to turn on a fan because one of my neighbors started playing music really loud, and I really don't want a copyright strike. So when the music turns off, I'll turn off the fan, and we won't have that hiss in the background. Oh, getting the link. Alright, got the link, almost there. Alright, I think we are all set. Absolutely, we're all set. Alright, we're live, everything's good. Got the live stream set up, tweeted it out. Alright, so first order of business. We're doing a giveaway. That's going to be really exciting. A giveaway of one of these dev kits from TI. It's one of the div kits we're going to be working with today. What we're doing is basically connecting to these 6 dev kits I have on my desk, and we're just going to hook them all up, get the IDEs set up, build a project, and upload some code. Just trying to show that it isn't that hard to get a new dev kit, plug it into the computer, even if it's not an Arduino. The Arduino is an awesome ecosystem with a lot of libraries and a lot of really good support. But there are other great ecosystems too. Granted, the new Arduinos have a lot of features that weren't there in the older versions, but there's other good parts too, specifically the Cypress PSOC. They have a really interesting methodology when it comes to microcontroller peripherals. And you can kind of get a hint of that in the graphic on the box. Instead of thinking of it as a fixed system, it's like you have different blocks that can be configured to behave in multiple ways, and then, you know, you turn them on however you want. Got a little IoT board, particle photon, super cheap, super tiny, meant to connect and use as a node just around your house. And then another general dev kit from ST with an STM32 processor, a different Cypress PSOC part, an Arduino Nano, because you can't talk about microcontrollers without an Arduino Nano, and then the TM4C123G dev kit. I suppose without further ado, I'll just get this started. I figure may as well start with something that isn't super new or super familiar. Just burn through the Arduino really quick. All right. Oh. Didn't quite get the 2 webcams configured perfectly yet, but I'm getting there. So, hope you're having a nice day, having a nice afternoon. We're going to kick this off with the Arduino IDE and the Arduino Nano. Good stuff. So step 1, I'm just going to take the USB cable here, plug it in. Sorry, got tangled up. So just plugging in the Arduino. This other circuitry is not doing anything. It's for the LED series, which there's a link to in the comments. It's part of that giveaway, but it's a really cool series. It's getting away from intense technical and just blowing off some steam with a fun LED project. So, yeah, like the plant light project, it's good. It's really intense. Probably a little daunting for someone who's just getting into electronics, so I'm just trying to pull that back a step or two, and yeah, trying to pull back the intensity 1 or 2 notches and do something that's fun and looks cool. And so yeah, check that out. Link in the description. Yeah, you know, like during the stream, after the stream, if I bore you, yeah, whatever. So this Arduino code, super easy. Go ahead, select our board. We're using a Nano. Select our COM port. I believe it's COM4. So setup, don't really need much there. And we just need a pin mode, or pin mode. Pin 13 has an LED on it, so we'll do 13 and then output. And that's just setting a bit in a register to a 1 so that the pin's configured correctly. And then all we need to do here is we'll do it the right way. So we'll have uint 32t old millis equals millis. So this is grabbing the current time in milliseconds. Then pin state equals 0. Bool. Right, and then if old millis, millis minus old millis is greater than 1,000, we will make pin state the opposite of what it was. Oh, I'm pretty sure that's how you do that, this IDE. I am not positive. Yeah, we'll just add another if statement in here. Okay. And we will send that out to pin 13. Perfect. Oh, important step. We need to set old millis equal to the current time in milliseconds again, otherwise, well, that's not going to do too much for us. Let's see if that compiles. Oh, missed semicolon. Compiling. All right, there we go. There we go. Ah. Sweet. So looks like it'll set up the pin to be an output, and then forever it will. Oh wait, we don't want to do this. This needs to be not here. So here's the thing that bothers me about the setup and loop system that they have in the Arduino IDE. It just really bothers me, because that means that if you want to modify something in your setup function and the loop function, I think you need to make it a global variable, which is just Weird and bad for object-oriented programming. Just weird and bad. You don't want to do that. So the way that you would normally do this is by having this nice loop here, and then while one, you break off into this subset of the code. So that's all this really is. If this was one function, it would be this is that setup function, and this is the loop, just an infinite loop with code that repeats. So, in fact, I'm going to put this here. And we are not going to use the setup function. Let's build this again. And I believe we are ready to test the first dev kit. So I'll switch back over to that camera. All right. Here we are. That's just the power light. And I will upload to the dev kit. Done uploading. Hey, we have a flashing LED. Wow. Hey, that's not bad for how many minutes we've been streaming? 12 minutes? Yeah, 12 minutes. Introduced the topic, told you about our giveaway, and finished writing one of the sketches for the Arduino IDE. Let me know how long it takes you to bring up an Arduino with a blink function in the comments. Because, hey, why not? We got to benchmark something. So let me know how fast you can write the code. Go from plugging in the Arduino to getting this code running. I'm curious to see. So this will be the fastest one by far because it's the Arduino and I'm very familiar with it. So, yeah. We'll see. We'll see. We'll see how the other ones go. But I'll leave that plugged in and blinking for this motivation, I guess. So that is the Arduino sketch. What's next? Well, I've got this particle getting started guide. I've got the particle IDE. Why not do that one? So we'll pull this out of the box. Oh, I switched cameras too soon. Switched cameras too soon. So we're gonna pull this photon out of the box. Really clever packaging. It's not ESD safe, but yeah, whatever. Beggars can't be choosers. Oh wait, I paid for it. No, it is a really cool. Oh, it isn't a little hunk of foam. That's better than nothing. Doesn't protect from me touching it, but I'm going to be touching it all the time anyway because it's a dev kit, so yeah. Cool, so we'll pull that out of the conductive foam because that's what we need to do. And we're actually not going to use... Oh, that is cool. Oh, this is the first time I actually took it out of the foam. I've been waiting for a cool project to do with it. That is a really cool graphic that they... Come on. There we go. It's a really cool graphic they have on that silk screen. That blue silk screen on the black solder mask. That just looks sharp. Alright. If the camera would focus, that would be great. Whatever. I give up. It's focused on the desk. So, we need a different USB cable. Plug this guy in. Cool. This one's got an LED too. All of the dev kits have an LED. It's almost required to have an LED to blink. It's also got a couple switches here. Opened up a COM port on the computer. It's actually getting a little warm on that. Is that the wireless transmission? I'm not seeing a micro. So yeah, everything must be underneath that little hood. Wonderful. I wonder if this is one of those like ESP, what is it, 3266? One of those boards, just rebranded and tweaked? Could be, but they're a cool company. They have this IDE, so yeah, why not? All right, so I have never used this IDE before. We'll see how it goes. Let's try. They have example code, so that could really speed us up. Packages. I don't know. I don't know about this. I was hoping for. Let's open a new project and see what this gives us. What is this called? My project. That sounds good. What is this? I clicked create. What does it want? All right. Apparently, I'm not going to do that. New project. Not quite sure what to do about that. All right, let's try this again. Let me just navigate in my file tree to somewhere that makes sense. New folder, particle. Do this. Select folder. Create. Okay. Weird. All right. Let's pull up Google on this one. Particle desktop IDE dev create new project. Let's see what they have to say about this. Particle guides. Particle dev is the desktop application. All of the commands are available from the particle menu. Let's logging in. Okay. Oh, you need to log in with your particle account. Oh, you have to be kidding me. Okay. That would explain why I can't build the project. This bothers me. This bothers me. Well, I'm going to fill this out real quick. Enjoy some music. Okay, I have a particle build account. Now I can probably log in to Particle Cloud. Wow, I am really glad that I am not showing my screen right now, because that just displays your password in plain text. Devs, get on that. Why did that not show up as stars? Holy cow. Alright, whatever. So, no device is selected. Okay, I think we are good. I'll switch back to the screen. Perfect. So there are example files. This web interface here is showing me example files for blinking LED, but this won't work because it can't send to target on this device because it's not connected to the internet yet because I'm crazy and I'm not using it how it was intended. This is meant to be very user-friendly, and like you build it online, connect it to the internet, and like it streams the new program over the internet to reprogram your device. But maybe I just don't believe in that. I know that no matter what I do, my code gets sent out to them, they build it, and then it comes back to me. But it just feels better when it doesn't get streamed to the device over Wi-Fi. That's pretty high level. That could be intercepted on its way back, and I guess if it's being compiled there, it could be intercepted on its way back no matter what. They could compile whatever they want and send it to the Photon. So maybe I just don't like that part of the ecosystem. But I'm trying to use the desktop app, not the web app. Okay. In Atom, you can do whatever. Hack, init script, console. Looking for examples. Looking for examples. What just happened? I said open file on GitHub. Huh. Just not seeing this. Maybe I'm blind. Though I wonder if I just make a new project. Oh, it says there are. They give me a link right here. All right. Wow, this is really. I don't know. Seems a little overcomplicated. I'm still not convinced I'll actually be able to send the program over USB, which needing to give this device my Wi-Fi password in order to execute a program to blink an LED seems a little excessive. Like, if you want to use the low-level functionality, maybe you have to reflash it with the fancy IoT stuff when you want to move on, but whatever, that's the base program. So, really, it should be okay. Huh? Yeah? Maybe? Okay, so I'm just going to take this off of that web interface and make a new project. Create. Hey! Now that I'm logged in, it'll actually let me. Okay. Yeah, good thing it didn't throw any error and just sat there and did nothing when I tried to open a project without recompiling. That's good. That's what you want. Okay. So, wait, this is this is an INO? Can I just flash this thing in the Arduino IDE? That would be hilarious. That's a Google search. Program particle in Arduino IDE. Wow, okay. You can just... Oh. Any reason you'd want to? No, not really, because you lose the library support when you use a different micro, so... Alright, so... Here's the example. Sounds good. See, this is the lazy way to do the blink, where you just halt the whole processor and sleep. It works for this example, but as you scale up, you need to use the counting milliseconds with a timer module to prevent hanging your processor doing nothing. So like if you want to update a display and wait a second, you need to actively wait, say, am I there yet? Am I there yet? Am I there yet? Am I there yet? And then, yeah, you know, you can move forward with that. So, all right, I need to how to upload to a device particle flash program to particle over USB without Wi-Fi connection. Yep. It's not that I can't use their Wi-Fi method, it just, I don't like it. Must be in listening mode when the LED is blinking blue. Though I wonder, is this hosting the Wi-Fi network? If this is hosting the Wi-Fi network, I like it a little better. Let's see if there's a new... Oh, there is! Okay, so I would connect my computer to the Photon, and then it would flash the program directly. So I like that better, because if I had to give that like my Wi-Fi credentials just to program it, nope, not gonna do it. Like, if that thing's connected to the internet, they know my location, they know my SSID, they know my password, they would know everything they need to know to break into my Wi-Fi network. Because my IP address, I'll get them close enough that if they drive around and look for that SSID, they'll probably figure it out pretty quick. Okay, so we got this tutorial here. It's in the listening mode. Oh, nice and quiet. Wonderful, wonderful, wonderful. Okay, so apparently I open the terminal and type particle setup. You saw nothing. Particle setup. What? Oh, this bothers. Oh, there's libraries. Oh, this is what I needed. This is what I needed. Oh, that's cool. It's got a bunch of... Wow. Wow. I like this a lot. Just sharing all these pieces of code, just building it in like that. I like it. I like it. Cool. This is a cool ecosystem. What's not cool is that this IDE doesn't want to show me the next flag for a while, so I have to like wait and wait, then wait, and then wait. What? I already... Okay. USB? Oh, serial, almost. Console, that's what I wanted. So I want to type part. What? I'm typing in the console and nothing is happening. What is this? What is this garbage? I'll just type it. No, none for me. Console, can I please type in the console? No. Oh, I need to download the command line installer. Actually, there's already a command line built into Windows? I'm just kidding. Why was this not packaged with the program. There's like a button to launch it. Okay, well, just let that install. Waiting for the installation. Sorry about that. Tried to get all the software installed, but I didn't realize there was a random command line installer that I would need to run in order to program my board with an IDE. Sorry, I can't help but laugh. The thought is ridiculous. It boggles the mind that I would need to install 2 packages for an IDE to connect to a device. I feel like this dev kit is definitely catering to a different audience than who I am. Like, with my frame of mind, there's a lot of just ain't gonna happen, not gonna work, game-breaking features. Just the look and feel of it is it's very polished, it's very simplified, which is really nice for someone who's just getting started. Maybe we should do a giveaway with some of these particle boards. But when you try to dive into the more advanced features of the microcontroller that you're working on, abstracting it too far can lose the detailed control that you need to properly interface with your peripherals. So I'm really seeing a lot of that. They're abstracting so much of the functionality where I think it'll be really hard to get it to do exactly what you want it to do. Like, even Arduino was struggling with that for a long time, a really long time, where if you wanted to set up like interrupts or a timer in a different way than default, because they do that by default already in every sketch behind the scenes, they set up all the timers and get everything running, so I don't need to do anything to get my millisecond counter, because so many people want a millisecond counter, they just do it by default. Which, yeah, but at any rate, so they've been adding functions to change those configurations and attach interrupts to pins, and they've been doing a lot of good work over there on the Arduino team. So it really makes it hard for any ecosystem to compete. Oh, come on. Sorry, it's installing things. It's installing things. Sorry about the screen flashes. So, 1 depreciation. Really? I just got this website, or I just got this off your website. Tell me there's already 1 depreciation. We might need to reboot this guy here. Particle dev. Let's do it. Console. Oh, come on. Really? 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 Okay. I'll give in. I'll connect to the Wi-Fi network. I'll do it. Thankfully, I have LAN, so it'll be okay. What am I even doing? Network internet settings. Oh. Let's connect to... Let us connect to Photon. Connect. There we go. We are connecting to the Photon. Okay. We're connected. So, let's... What do you mean no match is found? How do I connect? I'm like connected to your device. Okay, more steps. Connecting. Setting up a Photon. Just okay, there's Wi-Fi network. What? Why would I need? Sorry. Okay. So we've got their file. This is interesting. Hold down setup on, well, it's already blinking dark blue. Does this count as dark blue? Whatever. Yeah. Oh, they just rebooted it. Well, whatever. It's already there. I have to reconnect now, don't I? Oh, nope, says I'm still connected. All right. I'm connected to the photon. What do you mean waiting for you to connect? I'm connected. Well, so here's the thing. I might need to reboot to get the command line interface to actually work. I suspect that is the case because the console isn't working. And it appears as though the script for connecting to the photon doesn't work if I have an active internet connection because it's asking my router where the photon is and not asking the photon where the photon is. So I have two valid networking interfaces right now. And it's only asking the one where the photon is, so it can't see that it's connected yet. So, I mean, we're here. Well, for one, the LED was already blinking when we started, so check done. But we have the IDE here with the program, and it's set up to upload, and the only thing left to do is to turn off my internet, connect, and then upload. Which then you wouldn't be able to watch. So I can't do that. So we got close. We got real close with the particle. But the only way for me to finish would be to kill the live stream and start it again. And nobody's got time for that. So we'll have to move on. Well, I was correct. That one did take significantly longer. Let's do, yeah, why not? Let's do the Cypress PSOC. So, switch over to the desk. We're gonna do the PSOC now. Real cool. Comes with all these cables and whatnot. Really nice foam case. There's our Arduino still blinking. And we're gonna get this dev kit. Oh. Gotta unplug. No, I don't. They gave me another cable. Haha! Don't have to unplug our Arduino. Here we go. It is plugged in and powered on. Close out all this particle stuff. We will open up Cypress PSOC Creator. We will make a new project with the processor that is already selected. So just to tell you how I know which processor that is, I did this a few days ago, but I probably used this nice manual here. And oh yeah, micro 5 or 6 rather. Yeah, a nice line going around the 5 over to the 6. Intuitive. Yeah, so here it says it's the CY84247AZI-M485 processor. Household name. How could I have forgotten? Also, nice magnetic clasp. Like, they really... That's nice. It's the little things. The little things. It's the details. It's the details. But so we got our target device here. I'm going to choose an example. And let's start with something digital pins. Sounds right. That will probably get us pretty close to where we need to get. And we will build the project, build the workspace. So the cool thing about this environment is they have this graphical element to it, which is crazy. I don't even know what this is. Like, this is basically my experience with the Cypress development environment. They've got a lot of examples which will help. Basically an example for setting up every peripheral. So if you want to dive into this, you really can. It'll just, there's a learning curve. You're going to need to get over it and dedicate a few days to learning this. But basically it's all these blocks and you wire it all up and it just manages all the internal settings, and it's pretty great. So here, instead of having a line of code that would dictate what your output pin is, you just say, here's an output pin, and I'm sure in here somehow you can select which pin it is. Mapping, clocking, built-in. Yeah, I don't know. But what we need to worry about is it generated this low-level stuff with the clocking diagram and DMA, and nice. A lot of hard work they did for us. And what it comes down to is we got the C file here. Yeah. Output pin software write 0U? U? 0U? Really? What is that U for? Is that like selecting which pin? 1U, 0U. Weird. Okay. Let's compile. Let's compile. There we go. Compile. It failed. What? Oh, build, not compile, build. So we'll go through and check all the dependencies, pull them all in, I guess. Yeah, look at that. Look at all those dependencies that just showed up. Okay, build succeeded. And we will program. So I will program. Didn't I just... Yeah. Okay. So this is the demo program. Uses interrupts to toggle a pin. That's a good start. We just need to go from interrupts to it doing that automatically. So we have if input pin read global interrupt enable. So actually we don't need any of that. We just need like a delay statement. Alright, so input pin read equals 1U software pin control. So now here it calls software pin control. Input pin clear interrupt. Weird. So maybe when this output pin, maybe this turns off whatever was on before. Maybe that's what this does. So maybe this will toggle between 0 and 1. We'll just comment out this other code they have. All right. We just need a delay statement. Cypress psoc delay. Delay time accuracy. Void cy delay milliseconds. Okay. It's just, oh, I need to go like half screen. Cy delay. We'll give it 1,000 milliseconds. I'm not familiar enough with this. All right, we will build. Build succeeded. We will program. So this allows you to start flashing one color, or it'll. Oh. Yep. I see what we forgot. We forgot the loop. That's important. We need that. While one. Close that out. Build. Program. And now hopefully, wow, that program is fast. Did you see how fast? I mean, it's a small program. That was like build, compile, upload. That was awesome. So we got a green LED going on there. Cool. Cool. Now what I don't understand is how they change from green to red with this code. I have no clue how they're doing that. They do the same command. Oh, there's two buttons. There's two buttons. So they must have mapped each interrupt to a different button in this configurator thing. Well, that's cool. That's really cool. The whole point of the Cypress psoc thing is all these modules, you can turn them on and off, change their function. That's what's cool about these. So you don't waste any of your peripheral power by not using functions of it, where it's like, if you want all of your timer counters to do PWM generation, good. Set them all up to do PWM generation. You don't need to get a micro that's 3 times bigger to get enough PWM channels. That is their whole shtick with this series. Maybe that was a bad example, I'm not too familiar with it, but that's the general idea. It's, if there's a module that can be multi-purpose, and that multi-purpose module is usually underutilized by the software implementation, this gives you the freedom to implement it how you need to be successful. So, good. We have 2 flashing LEDs, 2 of them. 2 flashing LEDs. I think we need more. What do you think? I agree. Okay, so getting out the Tiva TM4C. Going to connect this processor as well. Now, I wasn't planning on having these all connected via USB at the same time. Whoa, the interrupts still work. That's weird. So that must be completely hardware offloaded, because there is no software running to make this happen anymore. I almost wonder if they're just hooked up directly to the LED and that wasn't the function at all. That'd be really funny. I'm like, I don't see how it's doing that, because it's a hardware button. Okay, well, I'm going to be right back. I'm going to grab some more USB cables for the rest of these dev kits, and then we'll have some fun. Just getting the cables. I found a few, not quite enough, but I found some jumper wires as well. So I might have to use a combination of the those wires and the new USB cables I found. So we're gonna need one open USB port on the hub I got on my desk. Got 3 spare USB cables at the moment. Yeah, this could work. This could work. So we have 3 more dev kits, and only 2 of them need a USB port. So we are golden. We are set. We are set. All right. Let me get hooked in. Welcome back, which is what you should be saying because you have been here the whole time, and I am the one who just left. Yeah. All right, we are getting it set up. So the nice thing about this IDE is we know that there's an example project that if we add these couple lines of code, it'll actually work. Like, we already have the code written. All we have to do is copy in this little while loop. So, well, there you go. This next one should be really easy. The only difference is that we need to use this dev kit instead of this dev kit. So maybe it's got a different processor on there. It probably has a different processor on there. But whatever, that's just a project setting, and it'll compile and it'll get pushed on here and we'll be good to go. So it says connect the board to your computer using the USB connector. Okay. This one does not tell me what processor is on it. That's a shame. Oh. That is a shame indeed. So we're gonna have to look this up. They gave me a website. Go to cypress.com/cy8c kit-043. Okay. That didn't work at all. CY8C kit-043. There we go. Only $10, which is really cool about this dev kit. If we did a giveaway of these, I could probably give away a whole bunch. Like, they're super cheap to ship. Just put them in a regular envelope. They really did a good job of getting this cost down, which I'm pretty happy about. It's, yeah, no complaints, right? It's got a programmer on there, it's got the chip itself, $10, and you can start development. It doesn't have all the LEDs and the niceness. Oh, it does have an LED though. Good. Oh, I was gonna be so disappointed if we didn't have an LED. Okay, well, all right. Let's pull this up. Nope. I'm still not seeing the name of the processor. This is the same. Really? Really? You're just a PSOC M4 series. Design the way you think. Well, I think you should give me the part number. Please and thanks. I'm trying to do a thing. How is that the quick start guide? At all? PSOC kit 4.3. Alright, looks like I'm just going to have to go on DigiKey or something to figure out what processor is on here. Which is a little backwards, but... MCU. Oops, that's... 400M device. Which one? ARM-based processor. Oh. Wait a minute. Is that literally the same processor? Is all I have to do is pair this to an... What? Oh, okay. Sure. Let's peel the tape off this. Yeah? You gonna... Oh, that didn't come off very well. Apparently they don't want you to reuse... What? Content? What? It says peel here, but peeling there didn't... What it... Oh, man. Well, that's not very cool. I cleaned off my desk, so I don't have my knife. I do have this piece of wire. Hopefully we can poke through and get in. Alright, nope. I need to go get my... need to go get that. RIP headphone users. Sorry, I forgot to mute the mic before I set it on the table. Okay. Back to peeling off the label. That was not very easy, but we're in, and we never have to do that again. Design the way you think. I see. I will do that. I think we should plug this in. Oh no, this is not going to be in frame. That, okay, just need to set it there. Sure, never mind the giant jumble of wires. So I'm just going to take this and I'm going to plug this into the USB port. All right, good so far. Let me try to tidy this up a little. It's pretty hard to tidy up a bunch of USB cables sitting on the desk. So, sorry about the clutter. Oh no. Just heard the Windows sound for something got unplugged. Looks, oh, there's a heartbeat going on. That's pretty neat. That is very neat. Wow. Okay, well, we're going to make it do something way less cool, and we're going to make it blink. Poor particle photon, just makes me sad. So I'll have to only work with this offline, but that's not too bad. Normally I'm offline anyway. Actually, that's a complete lie. I'm online pretty much most of the time, at least for something. It's pretty much ubiquitous at this point. Since I have my file server set up, I need to be connected to my home network to access pretty much anything. So that'd be, oh, but once I reboot, I will be able to use the USB programmer. So I'll get that into the final video. This is going to get cut down and then put into a final video, but yeah, that'll be in the final video, the blinking, but I can't do it live without killing the stream, so it's just the way it is. I'm just going to try to upload this to the other board. I'm just going to unplug this one for a moment and just hit upload. What? Did that just get programmed? Did that just work? Oh, it got programmed. Ha ha ha. But now it's the wrong pin. Oh no. Okay, there's more work to do. More work to do. We need to figure out how these digital pins work. All right. Let's try this again. Let's try program. It says that we should be... Maybe these lines don't actually do anything. Try we're controlling the green one. And the green LED is 2.6. Which one is that hooked up to? 1.6? Are any of these hooked up to 1.6? No. Okay. Then let's use 2.6. Yeah, so we need to look for 2.6 because that's what we're doing. 2.6. Output pin software. Okay. Output pin software. Output pin software. Interesting. So then how does output pin software turn into 0U? How does that become U? Oh, output pin software, right. Oh. Okay. Hey, I'm learning things. I'm being more than not at all useful. Look at me go. Okay, so I think, does this, I don't know if this does anything at all. Add, no. All right, so I'm just gonna go to pins, and I'm going to, what do we need to map? We need to map 1.6. 1.6. 1.1.6. How do I add a pin? How do I edit? How do I like, oh no. What? I need to like add a symbol. Okay, so now I have another pin. Digital output. External terminal pin. How do I assign you? We're gonna call this little PC. Oops. No, we'll just call it 1.7, right? Pin 1.6. Pin 1, 6. Okay. Yeah. Okay. Pin 1, 6. Oh, so did they give this an alias of U? Output pin software underscore 0. Output pin software underscore 1. Okay, is there a 0 in here or something? No. How does this get mapped to U? How does this get assigned to a pin? I don't understand. This is not intuitive. This is all stack and heap. Memory management. I don't see how to do what I need to do. I need to tell it which pin is going where. Alright, whatever. We're going to take to the internet. Cypress PSOC creator, add a digital output, or map a digital output. Place a digital output pins component configured in strong drive mode. Oh no, that's not what I meant to do. Call it my pin. What do you mean and assign it? How do you assign it? Hold me back. It'll be intuitively obvious how to assign the pin, because clearly. Alright, let's stare at this a little more. It is set as an output. Mapping. Contiguous. Okay. How do I place a new ports and pins digital output pin? What if I grab a new output pin? Will this just be intuitive now? If I do pin 1, 6. That's the one we're working with, right? Pin 1, 6. Yeah, we're working with pin 1, 6. Okay, let's just go through all the menus here. Min supply voltage, wasn't that specified? No, it wasn't. Okay. Digital output pin. Mapping. How? Or maybe now that we have that pin, oh, now that we created the pin, we can assign it. Oh my gosh. How intuitive. I should have known to go to a completely unrelated part of the program to do the second half of what I needed to do. Oh my gosh. I'm just glad I found it. Man, that was frustrating. That was really frustrating. So we don't need that other pin. We just need the pin 1.6. It's now mapped. This is just funny text. It doesn't actually matter. I think we'll be all right. Got our pin. Save that. It is now mapped. Save that. Pin _1_6. So I think what this is going to be is we need to make this pin _1_6 right. I think that's what we need to do. And just do that twice and make sure this one's 10. And I think that should be all we need. So now we're setting the pin for this board. Oh, you can't see. So now the code for this board will still be running. We still have the line that we need for that, output pin software right. And then we added the pin 1.6 right for this dev kit. So now both of them should have a flashing LED. And we have successfully mapped the pin in their tool, and everything should be all right. Let's try to build. Error, error, error. Terminal requires connection when it is visible. What do you mean requires connection? Can I just do this? Does that count? I don't even know what that block was. Is that a wire? Okay. Does this actually matter? Do I actually need to tell it that there's an LED here? Why would it care? Why? I veto this. I veto. Oh, wait a minute. It's because this is set up as the wrong kind of thing. This has hardware connection, external terminal. This one has hardware, does not have hardware connection. So that must be for the internal DMA. So now we just have the pin. Let's try that again. Build. Here I'm getting all bent out of shape about me not knowing how to use a tool. It's always painful. The learning curve is always steep with a new tool. This one in particular is vastly different from most tools because they're giving you a level of hardware configuration that you normally wouldn't have. So, yep, can confirm the LED is now blinking. Awesome. We have both of these dev kits blinking. That's what I like to see. And when I hit program, did that just program all of them that were connected simultaneously? No, just the one, just the one, just the one. All right, so we will upload to that one, make sure it still works. This one obviously still works, it was just programmed. Boo, yeah. This does not stick in USB ports very well. We gotta like break the USB port by reefing on it with this big lever. It's not wanting to connect to the USB port very well. Oh, whatever. It's got power. That's all it needs. Awesome. The PSOC. The PSOC is done. We got both of these. I actually learned how to use this tool. Holy cow. So I can talk about it a little more, I suppose. In this top level design, you can add on different things like an LCD or a communication bus or a CapSense thing. And then you can drop those in, wire them up how you need to with switches and whatnot. These do nothing. I don't think. If they do exist, I don't know where the switch came from, like how they got the components in there. I'll leave that up to you, but we just added an I/O pin and then controlled it in software. So, wonderful. Close that tool out. We don't need that anymore. On to the next challenge, the TI processor. We are working in Code Composer Studio. Code Composer Studio. Love it. Live it. Love it. We need a new project. And we need to use a Tiva TM4C123G TM4C123G. Oh wait, that's too many letters. Okay, filter text, TM4C123G. We have the GXL. Okay. Is there an X? There's no X. TM4C123G. I must be missing part of the part number. What processor do you have? I got the box here. So GXL must be the part number for the dev kit. What is the part number on the processor? See if I can catch it in the light just right. TM4C123G H6 86 PM. There we go. And we're going to call this Blink. And we will make Hello World. Finish. All right, so here we are in the IDE. We have something that'll print Hello World. I think this might just be to its internal debugger, because this has a JTAG programmer built into the board. That's what this is using. So I think we have pretty granular control of the micro at runtime, and that's what this printf is printing to. Hopefully they'll have some examples here. They have their TivaWare. Energia, that's actually, you know what? I bet I have Energia installed as well. We'll do it both ways. I just want to show you the option. So Energia is a port of the Arduino IDE, which is awesome. It's great because with this dev kit, you can start, get the micro configured, start working with it, and you can start in this Energia IDE, like learn the processor before you have to dive into managing a more complicated IDE. This is a very simple, streamlined IDE, but it gives a clear path to more advanced features. And that's what I love about the Tiva Launchpad series. It gives you that out-of-the-box ease of use with some, not as many, but some good libraries built for Energia and a pretty intuitive hardware abstraction layer code set that you can leverage, and lets you really get up and running quickly if you need to throw something together. But when you need that granular control of like swapping peripherals on and off, or you need to really get into the inner workings of this processor, I'd switch over to Code Composer. There's a little more overhead, there's a steeper learning curve, but hopefully you've already mastered what you need to know about the processor, and then you're just learning how to control the peripherals on a more intimate level rather than from a higher level with hardware abstraction layer code. So that's why I'm pushing this particular dev kit. That's why this dev kit is the one that we are giving away. It's because I like that you can start with Energia and then move on to the Code Composer when you feel more comfortable with programming. I think it's a great lineup for beginners who want to start just doing general
like if you want to get into a bunch of like modules like Wi-Fi and whatnot and like throw something together like the LED strip project, which link to the giveaway, you gotta leave a comment on that. So basically, yeah, lost my train of thought. Yeah, if you're trying to do that kind of stuff with the modules, this is not going to be as nice as an Arduino Mega. It's just not. This is not going to be as nice as an Arduino Do for that type of work. If you want to interface with analog digital sensors, maybe something over SPI, you're comfortable writing your own library and like digging through the data sheet, you can get to those advanced functions here. You can get to those advanced functions with this processor. It just, you're going to need to do a little more work, but when you're done, you know, you'll have learned a lot. You'll have learned a lot in the process. I don't know. I was just rambling. So we want an example. That is not a very helpful menu, okay? Examples, basics, blink. So yeah, I'll just show you what they got here for libraries so far. Wow, they got an accelerometer in here. Nice. Got an LCD. Bar graph, probably like an LED bar graph. All right. They have got some pretty good libraries here. Maybe I misspoke. Wow. That's pretty good. Their libraries are... Yeah, I mean, they got all the core ones here. It's, again, the add-ons for those extra modules where you're really going to not have the same level of contribution. It's not as popular as the Arduino series. Well, we will just grab the Blink script in Energia, and I will plug in the TIVA. So critical detail here. This is the right USB port. This one over here is for USB on the go functionality. So this is directly connected to that processor, but it can't be used for flashing. So you got to use the debugger interface. And I will switch over to desk view. We have our script. It's going to talk to the LED. Pin mode LED, red LED. So this is predefined with a pin map. For red LED, I'm sure that if we didn't want to use red LED, we could give it the pin that it's connected to, like a PF1, and that would work too. Like, if we compile this, PF1 will probably work. PF1? Did I mistype that? Oh, there's no port F. Okay, port C1. Like I said, port C1. Compile that. Error compiling. That pin port underscore maybe? Alright, I have to look this up. Energia enable an IO pin. Digital pins. What is pin? Energia pin mode. 14. What? They map to arbitrary numbers? Okay. Let's see if that's publicly available. TM4C123G Energia pin mapping. TM. Another good point is this is a 32-bit micro, not an 8 or 16-bit, so that's one thing that I like about it. The MSP432 is also a good season, or a good series. All right, let's find this pin mapping. Okay, yeah, so they just give them numbers. Not seeing the energy of numbers unless they're these. Use pin numbers only. Okay. Let's try doing port C1 the way that it is written in that datasheet. No, but if we say like 30, that'll work. Okay, so 30 works. All right, so we'll just do red LED. We'll use their HAL. Takes a while to compile and then upload. What in the world is that? What in the world is that? Excuse me while I frantically search. Yeah. Wasn't the intention. Maybe we should initialize all of the pins and just set them low. This might help. Let's try this. Oh my gosh. What? I hit save. What do you, oh, it says, it's prompting me to save the file. Oh no, what is that? What in the world is that? All right, that's an unpleasant glitch. Upload. So now I just initialized all the pins and turned them all off. Oh, wait, where's the code? Oh, it's there, it just wasn't showing it to me. All right, so that blue LED never really wants to turn off. I don't know if you can tell. It's just barely on. Can you tell that? It's difficult to know. Oh, yep. You can pick that up just a little bit. It's just the tiniest bit. The tiniest little bit blue. I don't understand why it's doing that. It's probably fine. But at any rate, so just to show what we got here, we'll switch over to the green LED. So reprogrammed with the green LED, now the green one's flashing. Program it with the blue LED, then the blue one will be flashing. So Energia gives us pretty nice control. Really easy to throw that together. Now how do we do that in Code Composer? I don't know. Let's find out. Run, open. All right, let me open this up. I'll show you the screen, give you some music. We'll be right back. I need to find TiVoware on my computer. Okay, so we found TiVoware. It is in C, users, whatever. All right, let's find that. We just want an example for blinking. It's GXL. So in this folder, in this folder, we have example files for a few different boards. Some of these do have capacitive sense built on, which is nice. But we're just going to go to this regular one. And now they have a bunch of Blinky, what we want. That's a strange name for it. But they have like the USB device opening a serial port that will just natively be detected by Windows and doesn't need drivers. It's all right, just a standard USB serial port. There is a standard driver for that, and I'm pretty sure that's what that's using. There might be a Tiva driver, that'd be less great, but yeah. We're gonna open up this Blinky project, and maybe it's already done for us. Okay. That looks like not what I needed to open. Where there's supposed to be like a file readme. Very simple example that, oh, .c, I found it. Haha, it was buried in all these other files. All right, so it included a couple libraries, so that's a good hint to which libraries you need to include. So it looks like it just counts a whole bunch. What? So instead of actually giving us a delay function, they're showing you what they're doing behind the scenes. They're just counting clock ticks. They're just add one, add one, add one, add one, add one. Oh, we added one enough times. Let's move on. But it looks good. So this makes a lot of sense, right? Port, base, port, pin. So I'm guessing that port F3 is hooked up to one of these LEDs. And so if we wanted to do port F2, you just put GPIO pin 2, or if you wanted to not control port F but port C, you'd put port C base, and that's all built in. Let's try to build and upload this. Let's see, project, build all. Looks good. Run. Why is debug the only option? All right, programming. And then I need to tell it to run. Is it? It's not doing anything. Did I goof it up? Did I do something wrong? Oh, that's wrong. Apparently I duplicated GPIO pin 3. That's probably not what we want to do. Oh, right. 'Cause this is writing directly to the register, so we need to do that. Maybe port F3 isn't actually what we need to map to make an LED blink. Let's see if in this pin mapping they told us which one has the LED on it. LED. Does not appear so. Oh, red LED. There it is. Port F1. What's green LED? Port F2. Port F3 is... That blue LED is weird. It's just on by default. Drives me nuts. So, what is happening? Let's pause. Let's see where we are. We went to the fault ISR. What? Why are we in the fault ISR? What? Well, that explains why it didn't... Oh, wait. Which code did I upload? I uploaded Blink. Oh, I'm such an smart and logical person. So we're going to control the blue LED because apparently it's on by default. And oh no, yeah, okay. Yeah, it's probably, if I reboot, maybe that would change. Apparently not. All right. We need to upload Blinky. We need to switch and make this active. How do I make this active? Build project. Debug as Code Composer debug session. That is still Blink. That's not what I want you to run. I want you to make this active. Okay, apparently I need to look up how to do this. Code Composer Studio switch active project. Clicking on file. Clicking on file tabs changes active project. Well, I'm clicking on the tab for the project. I'm clicking on the file folder. Like, what do you want from me? I guess I'll just delete that project I don't want, and then this one will become active. I don't even know. This is the only project. It's the only project now. If this doesn't work, I'm gonna have questions. I'm gonna have some questions. Okay, there are no recent launches. Okay. Build project. Did that do anything? I don't think that did anything. Import project. Browse. Let's try this again. Okay, we are going to import Blinky. Apparently I already did that. We'll just delete that. Yeah, delete that. We're gonna do this again. Okay. Import. What? We're going to import Blinky. See reason below. Okay. Oh, I'm on the wrong board. Silly me. So we need... Oh, wait. This is completely wrong. What am I even doing? Examples. Project? Boards. Yep. Okay. Search directory. Import Blinky. What in the world? Oh. Import. Import legacy projects. Okay. We were just here. Okay. Blinky. PJT. Okay. Not seeing that. Import CSS projects. Search. Blinky. Open the Resource Explorer. Okay. Man, this is the most work I've ever had to put into opening an example file. This integration is not great, like, at all. It's, yeah, pretty not great. Will you open the project? Please. Okay. Can't build. Oh, I think I know why. Properties, we need to select our processor. Or do we need to add a builder? Oh, that would be confusing. Okay, let's try this. Code Composer Studio Change Target Processor Project. Okay. Yep, change build configuration. Build configurations. Okay, project, build settings. Yep. Okay. Apparently I was not in the correct how to change target processor. Change target processor. Target processor. Resetting your target processor. No. Okay, let's do a new project. I think that's the issue here. I think we need to set the target. And so normally we would choose CSS project, and right here, how do I get to this screen? I don't know. Test. Finish. So let's go in here and look at project, properties, and look at build. Well, this is totally different. It's not what we saw here, was it? There's no build at all. Okay. Well, now this might be just a strange thought, but what if I just copy this and put it in here? And then build this project. Okay, not made because errors. Cannot open that. Okay, must need to point this back. Properties, we need to add that directory to this location. Okay. What is that called? Like build file source location? Include paths and options. That is, include options. Add directory to include. That's all I needed. So we need to point back to that TivaWare include folder. Oh, no, we just point it back to the TivaWare folder because it's asking for slash whatever, whatever, whatever. All right. Try that again. Build. Didn't work. During linking, unresolved symbols remain. Unidentified symbol, GPIO pin type, GPIO output. I'm not sure what that means. What if I do a more general search, like how to use TivaWare Code Composer Studio? Getting started with TivaWare. Naturally, why wouldn't I want you to be zoomed way over there? Install TivaWare. And Workshop Lab, okay. TivaWare. Okay, so we are looking for these symbols, which I presume are in the HAL. It's strange. It's strange. I'm just gonna copy all these things over. Oh no, that's not. Oh, there's that startup CSS, startup. I'm pretty sure we need that. I'm pretty sure we need that. So I'm gonna dig through those libraries again, find what we need. So right now what we're doing is we walked through a couple dev kits. We got the Arduino running a Blink program that we wrote where we're counting milliseconds instead of using delay statements. And then we were working in the Cypress PSOC creator, and we got this PSOC creator project up and running. And then that was uploaded to both this dev kit, the larger Explorer, and the smaller dev kit, this little USB stick that comes in this envelope. And now we're moving on to the TivaWare. We're trying to get the TivaWare linked up to Code Composer Studio, and yeah, get this LED blinking. We got it working in Energia. It's the Arduino IDE type environment. And it's really straightforward, really easy, just works. Like you see, it's blinking now, and really just running into errors with trying to use the hardware abstraction layer code built in. There's something wrong with the linker or the include path. There's some file that I'm missing. I think I might just need to copy over these startup files here, and then it'll start working. Okay, so we're in the TivaWare examples, boards, and we want the Blinky. Now we need the startup files. Can we drag those in and add them? Copy files. All right, let's try this again. Still just doesn't want to go. Using TivaWare HAL. Actually, you know what? I'm just going to search for this explicitly. I'm sure someone has it. Right, so I'm going to delete these files. They're causing a bunch of errors. Oh no, I think I needed that one. I didn't copy that one over. Only delete the files you added. Yeah, okay, we don't need those four. So we want to figure out this missing symbol error going on. Unresolved symbol. Resolved. Yep. What is this? It said it was resolved. I'm not seeing a resolution here. Or are these ads in the middle of the post? Okay, root cause. Played with it and it looks, the file path. This is Wow. So apparently this is so backwards that people like really struggle getting this set up. It really, and that just irks me. Like they put so much work, so much love into building all these libraries, then people can't figure out how to get the include paths right. Wow. Apparently need to include gpio.h. Okay. I am going to include this file that is apparently critical to making it work, which is kind of strange that they didn't add some sort of comment saying that we needed this. Though maybe that was the hardware memory map .h. Man. For how easy TI got Energia working for programming, this is really pretty backwards. I think I need to take a break from Code Composer, and we're going to switch over to the ST Dev Kit. All right. Can't possibly be worse than what we were just doing. Famous last words. Let's power this guy on. I've got the dev kit hooked in. Technically we were successful. We got this dev kit working. We have a project that will cause the LED to blink. If we could get the darn thing to link to the TiVoware, it's just, once you get that link to the TiVoware, open up that blinky, it would flash the LED. It's an old installation of TiVoware that's in a pretty convoluted directory, not like directly in this project workspace. I think maybe including that workspace. Oh, can we just include that whole workspace? We've been messing around with that for too long. Probably over half an hour just messing with TiVoware trying to get that linked, so I'm just going to let that one alone for now. You're just going to let that one alone. Okay. Blink. Oh, right. Pulling up. What's the last IDE we need? The IDE for the ST. It's like STM32 System Workbench for STM32. Okay, and then we need STM CubeMX. This is kind of a similar idea to what we were doing with the Cypress dev kit, where this ST dev kit will allow us to configure the peripherals in a certain way with like a wait, what why is this down? No, don't update, just make a new project. What is this? Yeah, okay, new project. Part number search. We are looking for our STM32 L475 V. I don't know if we need those. V G. There we go. All right, we will select this part. And now that we're in this ST configurator, all we need to know is which one of these is hooked up to their LED. And it didn't tell us that. That's a little strange. All right. IoT node LED pins. That is a terrible amount of search results. None of those are what I want. Pin mapping. Literally none of these are what I'm looking for. Oh, strange. That's pretty strange. All right, so I want LED. Buttons and LEDs. Oh, buttons. Okay. What? How many LEDs are on this board? I thought there was just the one. LED 6. Yeah, bicolor, red and green. Right now it's red. LD6. Why are you not telling me what pin that's hooked up to? Okay. LD6. Okay. So it looks like that'll just toggle between, yeah, so high will be one color, low will be a different color. Okay. Wait. That's the ST-Link LED. I don't want that LED. What is this documentation for? It's for the whole kit. We want to know about LD6, don't we? Or is that not the LED we're controlling? Must not be. What LED do we have control over? Hardware, buttons, and LEDs. Oh, okay, so there's an LED just on port A5 and port B14. We'll use port B14. Okay, so we're using port B14. So we find port B14, double click here, set that as a GPIO output. And then we move on, clock configuration, everything's set to default. 4 megahertz clock will be plenty. And yeah, I think that's all we need to do. So we got that mapped as a pin output. Pretty intuitive. All we have to do now is generate code. And we will call this test. We'll call this Blinky out of spite. Okay, and then this should hopefully show up in our Eclipse workspace. Where's the, what in the world is going on with this UI? View, oh boy, too many development environments in one day. That is just nuts. Or did I put that in the wrong open project? What? And we're looking for Eclipse. We want STM32 system workbench, open, file location. Here we are. This. Open it in that. All right, so then it shoves that file with an example project over here. For whatever reason, I can't see the Project Explorer at all. Just a little weird. This is not what I want. I'm just going to try closing the program and opening it again. Generate the code, open the project. Maybe I had to switch workspaces. Oh, please. Please stop that. Oh, yep, I was in the wrong. We are in software. We're in a different workspace. Well, there's your problem. Oh. I see. We're in there one step too deep. Okay. Let me fix this. Okay. Now let's build the code. Now that I've got it coming into the right project directory. Open the project. And Eclipse. Oh, you know what? I bet Eclipse is just stuck in debug mode. I always forget how they have like their workspace. There's two different versions of it. One of them that's useful and one of them that hides like all the settings from you. Hey! Hey! Got it working. Okay. So now that it's here. Wait, what? It's not here. Okay. It's looking for more of a, like, you know, opening the project is kind of what I was going for. Unless, oh, you know what? I bet I'm building it for the wrong tool. You can build for multiple tools in here. Oh no, I've got two of these open. All right, I gotta close both. I don't know which one's building what. Okay, now we're loading it up. Got this. Settings, we want to generate for not eWorm, but we want to do the STM32 thing. Yes. Because I was silly and I built that for the wrong tool. Generate source code, it'll shove it over, and now, hey, Blinky shows up. And if you're wondering what this workspace is for, this workspace is set up for our Project Darwin series, where I was messing around with this dev kit a little bit. Upcoming, just doing some legwork, so when we actually get to the week-to-week, I can keep up the pace. But now, here we have our main function. We initialize our GPIO, and all I need to know now is what the HAL function that we need to do GPIO stuff. I'm gonna guess it's in that basic HAL. Say pin. mx GPIO init. Oh, wait, GPIO.h. Okay, what functions do we have in here? Is it already in output mode? We want to output something. Okay, toggle pin. Sounds fine. GPIO X. Let us call this function once a second. In our main.c. While one, user code begin. We want to toggle the pin, and yeah, I'm not sure. GPIO type def. Oh, just GPIO X. So GPIO X. Huh. Oh, okay. GPIO pin 1, 2, 3, thrower. That's pretty straightforward. Pin. We need to figure out what the port is, because we need to give it the port and the pin. So we actually so we want pin, so we want GPIO pin, oh geez, what was it? We need pin 14. For this HAL, we give it GPIO pin 14, GPIO type def, GPIO X. I think we're gonna have to Google this one. STM32 IoT node, blink, and LED.
The other is
All right, no. That moment when you forget that you're currently streaming, so you can't watch a random YouTube video to figure out what there is. Resources. BOM, schematics, loading. No software examples. Wait. How are including a variety of examples? Examples. There are examples? File. How to get to examples. More than 100 examples. Okay. Examples. These examples use the HAL. Oh, so this would let me know. Where is it? STM cube. Right, I'll give him a shot. STM cube FW. I don't want web result. I want you to search my computer for this folder. No. Oh boy. Okay. Not seeing projects. Okay. Can I just see all of the search results? Hey, yeah, this one's the ones that I want. Okay, then we want B, this one, examples. Projects, board, applications. I just really want to see anything happen. Pretty much just anything. Let's take a look at proximity. Source, main. Did they call GPIO? Right pin. HAL GPIO init will show us what we need to know. That'll give us the port. Okay. Find HAL GPIO init. Okay. I feel like I'm in the wrong file here. Main.c. Man, I probably should have been able to figure that one out. GPIOB for port B. I don't know. There we go. Cross your fingers and build. Oh wait, and we need a delay. Yep. So there's a nice function here they have. It's called HAL delay. Ooh, boy, is that a lot of errors. I feel like we're missing a fundamental include here. Let's try building again. Unknown type. All right. Man, we are so close to the end. We are so close. All we have to do is get this LED blinking. So this seems like a pretty fundamental issue, saying that uint16t is not defined in ARM math. That seems like something we'll be able to rectify pretty quickly. Oh, man. All right, STM cube. No, this is STM32. System workbench. System workbench for STM32. Uint. Let's 16T not defined. Huh. Apparently, STM320. Let me just include this. See what happens. No such file or direction. File or directory. Okay. That's a little weird. That's not how this is supposed to work at all. Let me make sure this is the right settings. We are using System Workbench. Maybe this is slightly misconfigured. We'll just click OK. We'll do this again. Build more code. Set up CubeMX for System Workbench project generation. Hey, looks like it's going a lot better. I think I just had to, I had it copy over a bunch of files and it seemed to work. Okay, so now I just have a couple errors here. Bunch of just type def errors. That doesn't even make sense. Strange.
Oh, man, this thing scared the crap out of me. Bluetooth speaker with a dying battery. Jeez. Ugh. Well. All right, that's about all, Toolchain. Generate under root. Okay. I mean, that looks right. We'll just give it another go. And quite frankly, I've done this before. These other projects should build, right? Yeah, they just build. These are generated the same way. So I'm not sure. Yeah, I'm not sure what the difference is here. Have the same includes, oh,
No, that's a PID library. We don't need that. Yeah, so this guy just built. It says build finished. Nothing to be done. Won't even check. Alright, let's reboot this. Alright, rebooted it and now it works. That is awesome. Maybe there was a file that didn't get refreshed or something? I don't know. Let's hit run and make this thing work because yes. Let's switch over to the desk camera. Oh, rip headphone users. I'm so sorry. Just whipping the microphone around. Hopefully the compressor worked. Okay. Whew. I'm getting excited. I think we might have it. Last dev kit. It says it's blocked. Launching. Blinky. Oh, yes. Do you see that blinking LED? Oh. In fact, all of the blinking LEDs. All with 1 second. Oh, words cannot describe the sigh of relief. Oh, I was running out of time. This took about an hour and a half longer than I expected it would. But man, those HAL libraries for the TIVA, the STM32, that weird bug. I've done this a few times. I've never had that bug before. The Energia stuff goes really quick. I set up a project for this TIVA processor a long time ago. Maybe 2 years. That was when I was in school, and apparently I forgot how to link all those libraries. I had to do it once, but I must have forgot. So yeah, that's why in a lot of these projects that I do, I end up using the Arduino IDE. Unless there's something that really pushes me, like a feature that's in one of these other boards that really pushes me to it. Because the Arduino boards just work. They just work. And I don't need to fight around with a compiler or an IDE that isn't free. It just works. So, fortunately, one of these projects I'm working on actually requires the use of this more advanced processor. And I think you can see pretty clearly that, at least the way that I learn, this ecosystem makes a lot of sense to me. The way that you map the pins makes a lot of sense. The way that... there we go. Wait, what? Still no webcam? What? There we go. The way that... The way that you map the pins and get everything set up in the STM workbench software, that's pretty nice for me. Just like you click the pin, you assign it to a function, get to the more advanced stuff down the road, all that good stuff. Energia kind of makes sense for the for their TIVA boards. They need to work on getting that HAL integration better. It's like there's a lot less example code written for the STM32, but the tool is so much more intuitive that it feels more useful. To go through, they handed me a working project for this blink code in that tool, in their tool, and it took me, an hour to fail to import it and get everything linked so I could build the project? Now that I think about it, I bet they already have that built in their library, so I could have just grabbed the hex file and shot it onto the micro. But that's not getting it built. right? So when it comes to dev kits and I'm not using an Arduino, I've used the Tiva and I really like the way it programs over JTAG. It's hard to screw up. It just works. So I really like that about it. It's just, you need to get the project set up and you need to get the HAL linked and you need to get all the dependencies mapped out. There's some good tutorials online. I didn't happen to stumble upon any of them today, but I'll try to find a link to that and throw it in the description if I can. It really is a nice ecosystem, especially with the Energia for the rapid prototyping when you don't have time to get the proper library set up or the proper project set up. But the code generation on the STM32, I've been really, it's not perfect. Like the HAL functions, you really need to dig through their source code to find what you need, and that's not great. The documentation isn't really there, but once you know what you're looking for and you get it set up, it's pretty intuitive and it works. So yeah, we got the Cypress boards running. That was pretty cool. We got the Cube 32 board running. This is actually the first time I built my own project, wrote code, got it working on the Cypress, so that's cool. And then the micro for the Arduino, and we had the code set up for the Photon, but didn't quite finish that. Didn't quite finish it because of the actual upload process required me to disconnect from my local network, which had some implications for you folks across the way. Of course, the alternative to fix the problem was to restart my computer to get the COM port set up for command line, and well, that wasn't an option either since it would kill the stream to do that. So, hope you enjoyed watching me get frustrated. Maybe I said something funny, maybe you learned something. I'm going to try to boil down this 2.5 hour brain dump into a 7-minute video for you all, and that will end up being episode 1 of It Just Isn't That Hard, which clearly, since it took me 3 hours to accomplish this task, it wasn't that easy. No, right. The series is called It Just Isn't That Hard, and I really struggled at doing something that I'm calling easy, which it's work. It takes time. But I was doing 4 of them in one day. Right? Normally you'd start a project, you'd ramp onto the tool. I was opening some of these tools today for literally the first time ever, and ramped up from no knowledge of the tool to uploading a program, and we did that 3-4 times. Well, I've used Arduino before. And I've used Code Composer before, but I forgot how to use it, apparently. So I'm going to stop rambling. Hope you enjoyed. See ya.